Hey guys, in this example we're going to differentiate a couple of functions using the chain rule. So the functions I'm thinking of is this one, and then change it, mix it up a little bit by adding a little power to the top of that x there. Alright, let's start with A. So as you may recall from the module videos, when using the chain rule it's worth trying to identify what the inside function is and the outside function is. So here in part A, that's our inside function, and the outside function is the square root. So the inside function I'll call it as u, e to the u minus 3, and the outside function is the square root of whatever I've lifted out, which is u. And from the chain rule, the chain rule says that if you've got an inside-outside function, then dy dx can be separated out like this: dy du times du dx. So the derivatives have been chained together, multiplied together. All right, so let's work out each of them. Since y is the square root of u from above, the derivative of that might be more convenient to write that as u to the half. Then differentiating y with respect to u, our variable of interest in that particular component, you bring the power down and reduce the power by 1. We'll leave that at the moment. For the second guy, the function there is u is e to the x minus 3. So u is a function of x, and now we're asked to find the derivative of u in terms of x. And that's just differentiating the ex, which becomes ex, and the 3 differentiates to 0. So let's put that together. That will be 1/2 u to the minus half multiplied by e to the x. So that's a preliminary answer. To finish this off, we'll sub back the u. We'll sub back the u here back into the equation to make everything in terms of x. And if you like, you can rewrite that as, and that's the answer for that one. Let's turn to the second one. In the same way, you can probably see there's an inside function. Which we call u, so we'll probably use the chain rule again. But you might notice that there's also an x squared up here, which is you can think of as another inside function, v. So that's a function inside the u itself. So let's list it up. So v will be x squared. U will be e to the v minus 3, and y will be the square root of u. So maybe it's worth here just working out the derivatives briefly before putting into the chain rule. So dy du here, as in part A, will be 1/2 u to the minus a half. Du dv, since u is a function of v, will just be ev minus 0. And since v is a function of x, dv dx is just 2x. Okay. So now let's go back to our original equation, the one we were interested in. So dy dx. We're going to use the chain rule. So we're going to actually use, because we've got two inside functions, we're going to use the chain rule twice. So we might first do something like we split the dy dx into two components. and we'll put du there. Maybe it's better to write that as du. Oops, wrong color. That was du. And then at this point, we'll split the du dx into two other components. So that will be du dx. And what we've got here is dv, of course. As a check, you might just want to make sure that informal check, if you cancel off the dv's and the dus, you do recover dy dx, which you do. Okay. So let's just, at this point, it's just a matter of inserting all our calculations, ev2x, and then sub in all our functions in terms of x again. So that will be u to the minus half, where u was e to the v minus 3. E to the v is e to the x squared times 2x. And I've still got another e to the v to sub out here. So that will be e to the x squared minus 3 to the minus half e to the x squared times 2x. And I've got room, just enough room to maybe write it in this form here, to square root like that. And that should be our answer.